This module discusses about hypermetropia, which is otherwise called as long-sightedness. So a person who is having long-sightedness will be able to see the objects which are at a far off distance, but is not able to see the objects which are at a closer distance, or nearby objects he will not be able to see. This defect is generally seen in middle-aged people. Now, what are its causes? So now, when an object is closer or nearby, in that case, the image is formed behind the retina and therefore you are not able to see a clear image. Now, what are the causes for hypermetropia? The first cause is the eyeball becomes small. So, when the eyeball is becoming small, for a closer object, it is formed behind the retina. Similarly, when the eye lens is too long, so which means that it cannot contract beyond a particular limit, and so you are not able to see the objects which are at a closer distance. Now, how can it be corrected? It can be corrected by using convex lens of appropriate power. It's very important that you write there appropriate part or appropriate focal length.
Now we are going to see the ray diagram for a hypermetropic eye. In a hypermetropic eye, the person is not able to see the object which is placed at 25 centimeter. So this point is the object which is at 25 centimeter. So we are marking this N dash, which is the near point of the normal eye, and N is the near point of the hypermetropic eye. So from this position, the hypermetropic person is able to see. So when an object is placed at N, then your image is formed on the retina. So in that case, if the rays are coming from N, then your image is being formed on the retina. So you get a clear image. Any object which is placed at N or beyond N, the image will be clear. Now, if an object is placed at the near point of the normal eye, that is N dash, then in that case, you don't get the image clearly. So it is being formed behind the retina. So since the image is formed behind the retina, your image is not clear. So you get a defective eye. Now for this, we are doing a correction. The correction is being done by placing a convex lens of appropriate focal length. So now you have the object at N. So when the object is at N, and virtual image is formed at N. So object is at N dash, the virtual image is formed at N, which is the near point of the hypermetropic eye. So this virtual image acts as a virtual object for the eye lens. So an object which is at N, we have seen earlier, you get a clear image. So you get a clear image on the retina. Thereby, by placing a convex lens of appropriate focal length, the image is formed on the retina and the defect is being corrected.